Welcome to video lecturing on BSc First Sem Mathematics on matrices. So this is session 16. The learning objectives of this session was to understand the system of homogeneous equations, consistency of system of homogeneous equations, trivial solutions and non-trivial solutions. First, let us see about the system of linear equations. A system of equations in which each unknown appears in first degree only is called a system of linear equations. A system of m equations in n unknowns is represented as a11x1 plus a12x2 etc. up to a1nxn is equals to b1. Second equation is a21x1 plus a22x2 plus a23x3 etc. up to a2nxn is equals to b2. Like this we have m equations in n unknowns. The mth equation is am1x1 plus am2x2 plus etc. up to amnxn is equals to bm. The above system of equations can be written in matrix form as ax is equals to b, where a is the coefficient matrix of this system of equations. That is, the coefficients of unknowns in first equation are a11, a12, a13 etc. up to a1n. Similarly, the coefficients of unknowns, coefficients are here x1, x2 etc. up to xn. Their coefficients in second equations are a21, a22 etc. up to a2n. And lastly, the coefficients of x1, x2 etc. up to xn in mth equations are am1, am2 etc. up to amn. So this is a m by n matrix which is formed by the coefficients of the unknowns. And x is the coefficient matrix, x is the matrix of unknowns. Here the unknowns are x1, x2 etc. up to xn. It is a column matrix of order n by 1. And b is a column matrix formed by the constants of system of equations 1. That is, b is equals to a column matrix of order m by n whose element is b1, b2, b3 etc. up to bn. Next, let us see about the consistency of the system of equation. A system of equation is said to be consistent if the system possesses either one or infinite number of solutions. Means, a system of equations having a solution, that is, either it is infinite solution or a unique solution, then we can say that the system has a system is consistent. And inconsistent means if the system has no solution, then it is called inconsistent. First, let us see about the system of homogeneous linear equations. In the previous slide, we have seen that system of equations are a11x1 etc. up to a1nxn is equals to we have 0. If the RHS of the system of equations 1 are equals to 0, then such system of equations are known as homogeneous linear equations. And these homogeneous linear equations can be written in matrix form as Ax is equals to O, where A is the coefficient matrix of the system of equations 1 and X is the matrix of unknowns and O is the matrix of the RHS. Here the RHS are all equals to 0. So it is O is a null matrix of order m by 1. If the system is having solution means it has either a trivial solution or non-trivial solution. Trivial solution means any homogeneous system of equations possesses one solution, compulsory it is, namely x1 is equals to 0, x2 is equals to 0, xn is equals to 0, and this solution is called zero solution or trivial solution. Means if you take any equation, if the RHS is equals to 0 means one of its solution is definitely all the variables are equals to 0. If all the variables are equals to 0, then definitely the RHS is equals to 0. Therefore, this is every homogeneous system possesses one solution, that is namely x1, x2 etc. up to xn is equals to 0. Other than this also it has solution. It may have solution 1 or infinite number of solution. but trivial solution is compulsory for all homogeneous system of equations. And non-trivial solution means if at least one or more unknowns are is not equals to 0. That is, if suppose the system has n solutions, that is a system has n unknowns, no, x1, x2, etc. up to xm. In n unknowns, at least one unknown must be non-zero. Then we can say that the system has non-zero solution or non-trivial solution. The criterion for system of non-trivial solution. We have a theorem here. The system of equations Ax equals to O has a non-zero solution if and only if A is singular. I hope you know the meaning of singular. Singular means if the determinant is equals to 0, then we can say that this is matrix A is singular. First, suppose that Ax is equals to O has a non-zero solution. That is, there exists at least one linearly independent solution. This implies n minus r greater than 0, where r is equal to rank of A and n is number of columns of A. This implies n minus r or n is greater than r or r less than n. This is here we can say, here we have n minus r greater than 0. So from this we can say that here if you take r in this side, it becomes here n greater than r, or we can also write it as here r less than n. So that is here rank of A is less than order of the matrix A. This implies here determinant of A is equals to 0, that is A is singular. Conversely, suppose that A is singular, that is determinant of A is equals to 0. This implies here rank of A is less than order of the matrix A, and this implies here R less than n, or we can also write it as here n greater than R. This implies if you take R in this side, it becomes here n minus r, which is greater than 0. This implies Ax has at least one non-zero solution. Let us take some examples on this. Determine whether the system x plus 2y plus 3z equals to 0, 3x plus y plus 2z equals to 0, 2x plus 3y plus z equals to 0 possesses a non-trivial solution. Take solution. Given system has 3 equations in 3 unknowns, and this system to have a non-trivial solution, the coefficient matrix A must be singular. This we have studied in the previous theorem. That is, a system of equation is having non-zero solution or non-trivial solution only when the matrix A is singular. That is, determinant of A is equals to 0. That is, you have to find the determinant of A. Consider the matrix A. Here the coefficients matrix of these equations 1, 2, 3 first row, second row is 3, 1, 2 and third row is 2, 3, 1. Let us define determinant of this one. Expanding this one, you will get here. I hope all of you know this how to expand this 3 by 3 matrix. That is, first you have to take the first element in this first one you take 1, then 1 into leave this column and leave this row and cross multiply these two. That is 1 into bracket 1 minus 6. Next is minus. You take here first it is plus, then minus, then plus. We know this method of expanding 3 by 3 determinants. Then it is second element, what it may be, you have to take minus. Minus 2 into again here you have to leave this column and row, then cross multiply this. 3 into 1 is 3 minus 4. Then similarly third element here plus 3 into, again here you have to leave this column and this row, cross multiply the remaining elements. This is 9 minus 2. Now expand this one. Expanding this one you will get here 1 minus 6 is minus 5. After simplification you will get here it is equals to 18 and this is not equals to 0. So this means here determinant of A is not equals to 0. Hence we can say that system has non-trivial solution. Take one more example here. Find the value of lambda for which the system x plus 3y plus 2z equals to 0 comma x plus lambda y plus 3z equals to 0, comma x plus 5y plus 4z equals to 0 has a non-zero solution. Hence, find the complete solution of this one. Here you have to write the coefficient matrix A is equals to 1, 3, 2, 1 lambda 3, 1, 5, 4. This is the coefficient matrix. I hope all of you know this one. Since there are 3 equations and 3 unknowns, for the existence of non-trivial solutions, we have to find the determinant of A. Let us find the determinant of A here as we had in the previous case. Let us expand this one. 1 into 4 lambda minus 15 minus 3 into 4 minus 3, then plus 2 into 5 minus lambda. This we know. After simplification, we will get here lambda equals to 4. Thus, lambda equals to 4, we have determinant of A equals to 0, and hence the given system will have non-zero solution. So, to find the solution, you have to put the value of lambda in this matrix A, and next you have to find the rank of this matrix A. According to that, we can find the solution. So, in the next, we can put here lambda equals to 4. So, that is now to find the solution, we have to rewrite this system of equation A, that is rewriting the matrix A. Here you have to substitute the value of lambda. That we know here, lambda value we have substituted here, it is 4. Next is, this is equivalent. Here you have to use the row operations, that is, you have to reduce this matrix into echelon form. This you have studied in previous sessions, I think. We have to make these elements to be 0. We have to make these elements to be 0 here. For that, to make these two elements 0, for that you have to use here R2 changes to. We are changing R2 here, and we are also changing R3. So that is here, changing R2 means here, we have to R2 changes to R2 minus R1. You have to change this R2 here. So we are changing R2. R2 changes to R2 minus R1. R2 minus R1. Use these two rows. That is here R2 minus R1 means here corresponding elements you have to subtract. 1 minus 1 is 0. First you have to keep first row as it is. Second row is 4 minus 3 it is. This is 4 minus 3 is equals to 1 you will get here. 4 minus 3 is equals to, you will get 1. 4 minus 3 is equals to 1. This element you will get here. Then next element is here. Next element is, you have to subtract these two rows. No? So this is 3 minus 2. Corresponding elements you have to subtract. 3 minus 2 it is. 3 minus 2 is 1. Similarly, we are changing R3. R3 changes to R3 minus R1. You have to consider these two rows. R3 and R1. Again you have to subtract the corresponding elements. 1 minus 1 it is. 1 minus 1 is 0. Then next element is this one here, R3 minus R1. No? This is R3 minus R1. 5 minus 3 it is. 5 minus 3 is equals to 2. You will get this element. Similarly, third element here, 4 minus 2. 4 minus 2 is equals to, you will get here 2. So this is the row operations we have done here. Next is, we want to make these 2's also is equals to 0. For that you have to use here R3 changes to R3 minus, because here you want to make this one 0. So for this you have to see the elements in the previous row. There are 1, 1, 1. So if you make if you want to make these two elements 0, you have to change R3. R3 changes to R3 minus 2 times of R1. So that is here you will get here. You will get, so 0 minus 0 is 0. Then this is 2 minus 2 times of 1 it is. 2, it is like this here. 2 minus 2 times of 1. 2 minus 2 is equals to 0 you will get here. This element you will get. Similarly, for this also same here. 2 minus 2 times of, this is 2 minus 2 times of 1 it is. Again 2 minus 2 is equals to 0 you will get. Like this we will get here. Third row is equals to 0. We know this is the echelon form. So this implies here rank of this matrix is 2, because rank of the matrix means number of non-zero rows. Here there are 2 non-zero rows. Therefore we can say that here rank of this matrix is equals to 2, which is less than the number of unknowns. Then reconstructing the system of equations using final form of matrix A. That is here we can say that the first row is 1, 3, 2. we can write rewriting this one in equation form, that is x plus 3y plus 2z. That we can see here, x plus 3y plus 2z. Similarly, this second row is 0 1 1. This is 0x, no need to write. Y plus z is equals to, here we can write y plus z is equals to 0. See here, this equation 2 implies y is equals to minus z, and equation 1 implies here x is equals to, we take x is equals to, take 3y plus 2z in RSS, it becomes minus 3y plus 2z. So from this we can say that here x is equals to 3z. Here y value is now, y is minus z, substitute y value in this, that is minus 3 into minus z is plus z, so this is 3z minus 2z. This implies here x is equals to z. Here we cannot get the solution directly, you have to choose one value for any one variable. Let us choose z equals to k arbitrarily, so that here you have to choose here z is equals to k, because here y is also in terms of z, here we have y is in terms of z, x is also in terms of z. You have to choose z is equals to k, some arbitrary value. Then this implies here z is equals to k, so that x is equals to, we have here x is equals to z, put z equals to k in this, you will get x is equals to k. And y is equals to, we have here what? Minus z. So we have to chosen here z equals to k. This implies y is equals to minus k. So hence we have here x is equals to k, y is equals to minus k, and z is equals to k, which represents the complete solution of the given system of equations. So this is about the solution. Now I have given here some multiple choice questions. You have to solve these yourself. If you find any difficulties, then you can ask your teacher. Otherwise you can ask in the college also. These are all some multiple choice questions.